coders, this is Coding Cleverly with another video. So today's 37th video is going to be about function templates. What we discussed last time was about pure virtual functions and functions which were abstract functions and function overriding. You could see cards that are popping, and you might want to check that out before watching this video because some of the concepts are going to be applied in this video, especially function overloading. So function overloading was basically about when functions could have different manipulations and have variety of input parameters and varieties of our return types. So when we have this kind of variation in our functionality, we could get more flexible with our code, and we are used to maintain and use it in a very easy and sufficient way. So this is what functions do, and what we want to talk about today is something that is very simple and yet powerful. It's about function templates. Now, function templates are special functions that can operate with generic types. Now, generic means something very general. The foundation of generic programming, which involves writing code in a way that is independent of any particular type. A template parameter is a special kind of parameter that can be used to pass a type as argument. So basically, you don't have to just specify whatever data type you have. You will have to have a specific category of types. So you just give it a generic type. And like a regular function, parameters can be used to pass values to a function. So like regular functions, parameters will be used, but they are called generic parameters. So template parameters allow to pass also types to a function. So this thing here is that it's a blueprint or formula for creating a generic class or a function. So there are two types of functions. One is called the function template and one is called the class template. In this video, we're going to be discussing about function templates. Later on, we will discuss about class templates. So what function templates are? Special functions that can operate with the generic types, helps to reuse our code. Generic programming can be used for different data types. Now quickly, let's jump on to my development environment, and I just want to give you a clear cut of what we're trying to do today. So we're basically going to try to use the function overloading concept here and gonna make some functions and then use them in our main logic, and then we'll discuss what function templates could do and how easy our code be. The less the lines of code, the easier we could maintain the code. So let's quickly jump into our development environment, and I would like to recommend you to type along with me as I do with all the other videos. The more you type, the better you will be. So basically, you should type. So let's start by including our return 0, and what I want to do here, I want to create functions. So I'll create one as called int add, and it will basically add two numbers. So I would have like int a and int b, and it will return me the addition of both, so a plus b, and it would give me this kind of value. Now would have something similar to that, would have something which is called float, which is the return type, and I would say float, and I would call it add, and it would have two input parameters. One would be a and the other will be b, and what we'll have is return a plus b. Now this is a float case. Then we have a double, and basically this is the concept of function overloading. We're overloading this function with different types of parameters, data types, as well as the sequence of how we could do this. So we have double b, and then we return this by a plus b. So what we could do here is that we could also, I'll create one more that will have a double return type. It will be add, it would have an integer a, it would have a float b, and it would have a double c, and it would return all three of the additions. So it's just going to basically return a plus b plus c. So it's just going to return all of this. So this is my function base over here. I created 4 functions, 1, 2, 3, and 4. So these functions are basically addition functions, and I'm overloading them with the same input name, which is the identifier. The return types are different. Their input parameters can be different, and the sequence of the input parameters could also be different, but they do the same kind of logic. Now what I do want to here is basically I want to give a console output, and I would say addition of, I would say, 2 numbers. So I would say addition of 2 numbers, and I would give the input over here. So I would say A plus B. I would say add, and then I would give the addition to this. So I would basically want to save this code in the beginning. So I would save this. I would put over here code, and I would give over here 24. So essentially, I created a prompt that says addition of two numbers, and it gets this invokes the add function, and what it does is gets any kind of input parameters. I would give as 3 and 6. Now, what I do is I'm gonna give the end line over here, and I'm gonna save this code, and I will also execute this. I'm supposed to get the answer, which is 9. So I get addition of two numbers, 9. That is correct. Now what happens if I want to use another function? Well, I copy this snippet, I control C this, and I go and control V this. And what if I just want to modify it by using in floats? So I do 4, 5, and I'll say over here as 6, 7. But I put the F sign over here, which indicates by default that this is a float data type and not a double, because we're explicitly telling the compiler we're using floats, or else we'll have a double. So I would save this, I would execute, and hopefully my second one, which is both floats, will execute. So let's see. And there you see 10.12. Now if I want to use my other function, so what I do the same exact thing, is I copy this code and I paste it right here. And now what I want is I want to change it up to have the last function, which is the fourth one. And for that, it would need a one integer, it would need a float, and it would also need a double. So in a double case, I don't have to mention if it's a double or not. So I could just write anything I want. I would save this code and I would execute, and you could see my fourth function working. And you could see here you go 55.21, it's working. So this is function overloading. So now what I want to do is I want to create a template that can make my ease more easy. So what I could do is I basically want to comment this out. So I'll comment it out, and then I'll do something else over here. And now what I could do is instead of writing so much functions and creating so much code, I could make this all succinct and easy by writing this simple keyword template. And then I would mention these two angle brackets, and inside I would put another keyword type name. And I would put capital T. I could put capital U, I could put a capital Y, capital B, whatever I want. For this case, I'll put capital T. And then what I want to do here is that I'm going to go put an enter line, and then after that, I would put T, and then add. This is my function, so this is my return type. Suppose this is some kind of return type, and this is my identifier. And I would do is, I would create this, and then inside I would put TX, and I would put TY. And what I would do is I would put this, and then I would return X plus Y. So what happens here is that T is any kind of identifier. It's a universal type. It would have its addition with any X or any kind of Y. So if I want to activate this code, I would like to comment this out. There's all blob of code. And what I would do is basically use this instead. So where I have two numbers, I would cut this one out in case right now, and we have two numbers. So it's add 3, 6. So instead of doing all of this with so much functions, I would have to put these angle brackets inside. I will just mention my type, and hopefully this will work. So let me comment this one out so I could demonstrate the first one. So I would execute, compile and run, and you would see 9 is working. So my template function is working. Now I would do this, and instead of that, I would tell the compiler that this one is not integer, but it's a float. So I would mention that inside of my angle brackets, execute, compile and run, and there you go, the exact same result as previously. Okay, now what I want to do here is I want to create that question what we had. The question what we had is what happens if we have 3 numbers, and there's no kind of issue to that, and we could do a mixed range to that as well. So what we do here is I would say copy this, I would paste this over here, and for instance if I have 3 numbers, I would say over here 3. So what we have here is that we could tell whatever the return type is. So the biggest return type for my case, I would have double. So I would have a double, and what I would do is I want to do this kind of implementation where the first one is an integer, the second one is a float, and the third one is a double. So what I would do here is I would do like this. I would do 3. I would do this as a float, and then the last one I would create as a double, so any random value, and the return type is double. So I would have to fix up this code as well. So here what I'm gonna do is basically I'm gonna define a type name, and it will also have another type. So I would say type name, and it will have a U, and then it would have another type name, and it would have a Z. So what happens here is now I created any kind of identifier for here. You could create whatever you would like. So what I would do here is that it would have one kind of type from T, it would have one kind of type from U, and it would have another kind of type from Z. So it would have another kind of type from Z, and we would say something like XYZ, small z. So over here what would happen is that it will add all of them, and it will add that, and we would see that the double is over here, the third one indicated. So the Z for us is considered as a double. So what we'd do is that the return type will also be double. So I would put Z over here in the return case. And now I would save my code, I would execute and compile and run, and hopefully I'll get right. Okay, now over here I'm having no matching function for call to add int. Now the reason for this is that I'm using this kind of template, and it's not designed for these two. I would have to comment this code out for these two, and this will only work for those. So what I would do is I would comment this, I would execute and compile and run. And now you would see our code is successfully running. Addition of 3 numbers, 13.11. You could get a calculator and verify if this is correct or not. And the other thing that is true about it is that the return type is also a double. And that is what we wanted. So for instance, if I don't want a double, I want an integer. How can I do that? It was 13.11. And if I want an integer, I would basically do this as T, U, and Z. And I know that T is represented as an integer, so I would just put T as the return type. And in this case, we'll have 13 instead of 0.11 because that will be truncated. So I would rebuild all, and we'll see if it's executing. So compile and run, and you would see 13.11, the return type, which is over here, double would be turning into an int. So save this code, execute, compile, and run. And here you go, 13 is the answer. So that was it with this program, and that was it with this video. I'll see you in the next one. Peace.